I'm going to go quite quickly through 6 examples of using separation of variables to solve differential equations to help you get an idea of the method and techniques involved. First thing we're going to do is we're going to multiply both sides by dx. 2x minus 3x minus 1 dy equals 2x minus 1 y dx. Now on the right hand side of the equation here we've got a dx, so there can't be any terms with y in here. We've got a term with y in, there it is, so I need to divide both sides by y. Like this, just to make sure that there's no y's terms on that side. Now we check the left hand side. This is dy, so there can't be any terms to do with x on this side. It has to be all y's, which means I need to divide by 2x minus 3, x minus 1. Okay, I'm now ready to integrate because on this side it's dy and everything's to do with y, and on this side it's dx and everything's to do with x. Okay, left hand side is nice and easy, ln y. Right hand side is going to need partial fractions, so I'll do that over the other side. Okay. 2x minus 1 over 2x minus 3 times x minus 1 is going to equal something over 2x minus 3 and something else over x minus 1. Cross multiplying, we get 2x minus 1 is a x minus 1 plus b 2x minus 3. Putting in x is 1 gives us 1 equals minus b, so b is minus 1. And putting in x is 0 is going to give me minus 1 is minus a minus 3b, which is plus 3, so a is 2. No, 4. A is 4. Okay, so a is 4 and b is minus 1, and obviously before I went any further with this I would check it by putting something like x is 2 into the left hand side and putting something like x is 2, same thing, into the right hand side and just checking it comes out the same. So I'll just pause the video and do that now just to check that I'm right. Yep, that's all okay, we're good to carry on. Okay, so my integral on the right hand side down here can be written as 4 over 2x minus 3 minus 1 over x minus 1 dx, which integrates to, okay, I've got ln 2x minus 3, I need a half to compensate, and there's the 4 that was on the top, and then I've got ln x minus 1 with no compensation needed plus c. Okay, now I'm going to actually carry on with this one and show you how to tidy it up and make it look as nice as possible. So I'm going to start by moving that 2 to be a power, just fiddling around with logs really the way you're used to from C2. Just one little thing coming up that you haven't seen before. So let's put these two together, the ln of the x term. So I've got 2x minus 3 squared on the top and x minus 1 on the bottom. Now I've got this plus c. Now I'd really like to somehow incorporate that plus c in with this ln so that I can then cancel the two ln's by doing e to the power of to both sides. I can do this two ways, I'll show you both ways. First way I'm just going to do e to the power of to both sides as it is. So e to the ln y is just y. E to the, well I've got to do e to the whole right hand side here. 2x, and it's really important not to individually e things. Okay, now this is not e to the ln blah 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 plus e to the c. No, 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 that's what goes wrong. We mustn't let this happen. Okay, the rule of indices that we're looking for here is x to the a plus b. Here's our a. Here's our b is equal to the x to the a times x to the b. So this is equal to y equals e to the ln 2x minus 3 squared over x minus 1 times e to the c. Now these e and ln cancels because log to base e is the opposite of e to the power of, giving us 2x minus 3 squared over x minus 1. And instead of e to the c, we normally just call it a, because it's just a number. E to the c is just a number, so we normally call it a. Now the other thing that we can do, it's quite clever, is that we can leave it as ln y for a minute, is ln 2x minus 3 squared over x minus 1, and instead of plus c I'm going to put plus ln k, In the same way that down here, instead of e to the c, I wrote a, because a is just a number and e to the c is just a number. C is just a number, so I could write it as ln of k, where k is a different number from c, but this is still just a number. And now I can use my laws of logs on the right hand side and pull that k in as a multiplier in front of the 2x minus 3 squared over x minus 1. And now I can just cancel my ln's by doing e to the power of to both sides, and I get exactly the same thing, obviously, but with a k instead of an a. You can call it an a, you can call it whatever letter you like, really. Next example, let's start by multiplying both sides by dt, 20 minus kv dt, remembering to put those brackets around the 20 minus kv. Now, we need to check our right hand side. We can't have anything to do with v this side, it has to all be t's. So this whole term is going to have to divide over onto the other side. Kv dv equals dt. Now let's check our left hand side. This has to all be v's, no t's, which it is, good. That means we can now integrate. So on the left hand side we've got ln, we've got 20 minus kv, which means we need a minus 1 over k to compensate for the derivative of that baby in the chain rule. And on the right hand side we've got the integral of 1, which is t, when we're integrating with respect to t, plus c. Now again, let's see what tidying up we can do with this, see how nice we can make it look. Let's start by multiplying both sides by minus k. So ln 20 minus kv equals minus kt plus, no, minus even, minus kc. I'll just leave it as kc for now, actually, although I could just write that as a or something like that. Now I'm going to do e to the power of to both sides. 20 minus kv is e to the minus kt minus kc, which is, using our rules of indices, e to the minus kt times e to the minus kc. Now this e to the minus kc here, k is just a number, c is just a number. This is just a number, so I'm just going to call this a. So what I've actually got is 20 minus kv equals a e to the minus kt, like that. Right, now what should I do? I will put that kv on the other side and this on the other side, and it's going to say kv equals 20 minus a e to the minus kt. Okay, we're getting somewhere. Dividing through by k, v equals 1 over k, 20 minus a e to the minus kt, and then using some information about what v is when t is 0 and what v is when t is 10 or something, we'd be able to find the value of k and the value of a. Second to last one, you know what we're going to do to start. We're going to multiply both sides by dt, and we're going to remember those all-important brackets around the 2v minus 450. We're going to check our right-hand side. Uh-oh, that's got v's in it. That's going to have to go on the left. Minus 15 over 2v minus 450 dv equals dt. Let's check our left-hand side. Yep, we're okay. There's no t's there. We can go ahead and integrate. Alright, on the left hand side we've got minus 15 there, and this has come from ln. It was ln 2v minus 450, but we need to compensate for that too, so I'll put a divide by 2 on that side at the front. Then on the right hand side, the integral of 1 with respect to t is t, and then plus c. So ln of 2v minus 450 equals 2 over 15 minus 2 over 15t plus, oh, shall I bother with it really, shall I? See, I could write minus 15c over 2, but 15c over 2 is just a number, isn't it? That's just d, so I'll just call that d. It's just a number. If it's just a number, it can just be written as d or c or whatever. So, ln 2v minus 450 equals minus 2 over 15t minus d. So 2v minus 450 is e to the minus 2 over 15t minus d, which, using our rules of indices very carefully, is e to the minus 2 over 15t times e to the d. Oh, e to the d is just a number, isn't it? Let's just call it a. A e to the minus 2 over 15t. Okay, let's add that 450 and divide by 2. V equals a over 2 e to the minus 2 over 15t plus 450 over 2, which is 225. But look at that a over 2. Let's just call that b. It's just a number after all. 2 over 15t plus 225. And then if we had some conditions, like when t is 0, v is 10 or something, we could find out what b is. Last one, isn't it lovely? Let's just start in the usual way. Let's multiply that both sides by dx. And then check both sides to see if anything needs to multiply or divide over. Okay, right hand side, we've definitely got problems here. We've got two terms, y and y plus 1. Let's put them on the left hand side. Sine squared of x plus pi by 6 divided by y plus 1 dy is equal to 2x dx. Okay, let's check our left hand side. This is all okay, this is dy, so no, this term here, the sine squared x plus pi by 6, that's got to go on the other side. Let's divide that under. So we get 1 over y plus 1 dy equals 2x over sine squared x plus pi by 6 dx, and now we're okay to stick those integrals on. Now both sides of this look disgusting, but I'm going to do some partial fractions on the left hand side, and I'm going to do something clever on the right hand side, and then it'll all be okay. Right, left hand side. What have we got? 1 over y plus 1 is going to equal something over y plus something else over y plus 1. Cross multiplying gives us y plus 1 plus by equals 1, and letting y equal 0, I get 1 equals a. Letting y equal minus 1, I get 1 equal to minus b. So I've got a 1 here and I've got a minus 1 up here, and then I can use that on my integration. So this is 1 over y minus 1 over y plus 1, and obviously I would never go ahead and do this without actually checking, equals 2x, and instead of divided by sine squared I'm going to write cos x squared pi plus x plus pi by 6. Okay, left hand side, ln y minus ln y plus 1 equals, now what are we going to do here? Well, we're going to use integration by parts. U is going to be 2x, the derivative of u, nice and easy too. The derivative of v is going to be cos x squared x plus pi by 6, and I know how to integrate that because that's one of my derivatives. That's come from cot of x plus pi by 6, because the derivative of cot is minus cos x squared. I'm going to need a minus there to compensate. Dunk dunk, this is equal to 2 minus 2x cot x plus pi by 6 minus the integral of, and then the v times the du. I'm going to pull out the minus in the integral and also the 2. So I'm going to put the minus and the 2 at the front, and then that will leave me with cot x plus pi by 6 dx. Now you might be saying, but what's the integral of cot? But the integral of cot, well, that's just spot the dog. The integral of cot x dx is the integral of cos x over sine x, and there you're spotting there the cos x on the top, so you can see that this has come from ln sine x. Derivative of sine is cos, that's why it's on the top. So what we end up with is ln y over y plus 1 equals minus 2x cot x plus pi by 6 plus 2 ln sine x plus pi by 6. Now tell me that wasn't fun. Plus c.